Exam 4, page 2, section 1, question number 2. And the question says, consider the function x squared plus 4x minus 2. Provide a left-hand endpoint estimation of the area under the graph of f of x between x equals -6 and x equals 4 using n equals 5 rectangles. So I've got our interval and n, and then I also have the equation put for the left-hand approximation. And with the left, we're always going to be starting with x naught, or -1. So then we're going to find delta x because we haven't calculated that. So that's going to be b minus a, so ab, and then it'll be 4, and then minus a -6, it will be plus 6, and then over n, which is 5, so 10 over 5, and that's going to equal 2. So then we need to determine our left-hand endpoints. And so we'll be doing first x of I minus 1 is equal to a plus I minus 1 and delta x. So this equation for us is going to equal -6 because that's a, and then it'll be plus I minus 1 is going to stay, and then delta x is 2. So that's our xi minus 1. So then we're going to put that into this equation right where it's supposed to be. So it's going to be L of 5, well, I guess I can't say that yet, but it'll be this I equals 1, 5 for n, and then it'll be f, and then of the equation that we just determined, I minus 1, etc., and then multiplied by 2, and then what we're going to do is move this 2 all the way in front here, because it's a constant, so it'll be the same thing. We're going to move it to the front. And then it'll be 2. And then that will be our equation. But what we do know also is we're trying to get the area. So the area is going to be equal to, it's going to be delta x, which is our 2. And then we need to determine, before we start putting things in, we know that the width of the rectangles is 2. So every number between here should be 2 apart. So left-hand endpoints, we're going to determine those endpoints. And then it's going to start at -6 because that's our A. It's going to be -6. And then we're just going to add 2. So this is also the from. And then it's going to go 2. So it's going to go plus 2, so -4, -2, 0, 2, and then it'll be stopped here. We won't do 4 because it's a left-hand endpoint and not a right-hand approximation. So then it's going to be to this last number, so it's going to be 4, this is going to be 2, this is going to be 0, this is going to be 2, and then this is going to be 2, 4. And then we're going to plug this into this number. So we're going to plug it in. We're going to do f of x. So this original equation of x. And then we're gonna put in -6, -4, all those values. And so f -6 equaled 10. And then f of -4 is going to be equal to -2. F of -2 is going to be equal to -6. F of 0 is going to 6, 4, 2. And then f of 0, sorry, it's going to be equal to -2. And then f of 2 is going to be equal to 4. Oh, 10. My bad. Now we're going to start filling out because now we know from and where it's going to and how big it is because of the delta x. So we're basically just going to do all of these values added together to get the area. So f of -6 plus f of -4, and then it's going to be plus f of -2 plus f of 0 plus f of 2. And that's going to give us our area. And since we calculated everything already, all we have to do is put in the numbers. So you know that delta x is 2, and then f of 6, it's going to be 10 plus -2 plus -6 plus -2 plus 10. And then this will all add up to 10, or equal 10. So then we're left with 2 times 10, and then that equals 20. So our final answer is 20. And that's going to be a left-hand estimation point of the area.